Hey everyone, welcome back to this channel. If you watched the last video, you know we cracked the first sequence from problem A, where we discovered a quadratic pattern. If you miss it, go check that video out, it will help you get up to speed. Now we are moving on to the second sequence, which is little trickier. Here how it goes: 1, 2, 8, 48, 384 and 3840. Looks a bit complicated, right? But don't worry, we will figure this out together. So without wasting more time, we will directly solve our problem. The second sequence is 1, 2, 8, 48, 384, 3840. The first step, just like before, is to look at how the term changes. But this time, instead of difference, let's look at the ratio between the consecutive terms. So step 1 is calculate the ratio, that is, find the ratio between the successive terms. So first term of this sequence is 1, second term is 2, third term is 8, fourth term is 48, fifth term is 384 and sixth term is 3840. So now we will take the ratio of the successive term, that is our first term of the sequence is 1 and second term is 2. So we will take the ratio as 2 upon 1 is equal to 2. Okay, so now the third term of this sequence is 8 and second term of this sequence is 2, so 8 upon 2 is equal to 4. Now fourth term of this sequence is 48 and third term of this sequence is 8, so 48 upon 8 is equal to 6. Now fifth term of this sequence is 384 and fourth term of this sequence is 48, so 384 upon 48 is equal to 8. So now the sixth term of this sequence is 3840 and fifth term of the sequence is 3000. So now sixth term of the sequence is 3800. So now sixth term of this sequence is 3840 and fifth term of the sequence is 384, and so 3840 upon 384 is equal to 10. So the ratios are 2, 4, 6, 8, 10, increasing by constant value of 2. Okay, now we will calculate our next step, step number 2, and we will give name to this step as a hypothesize the pattern. So what happened here? Each term is being multiplied by the number that depend on its position in the sequence. Specifically, each term is multiplied by 2 into n minus 1, where n is the position of the term. Okay, so step 2 is hypothesize the pattern. The sequence grows by multiplying each term by an increasing factor 2 into n minus 1, where n is the term position. For example, we will give a name to the first term as a b1. Okay, so b1 is equal to 1. So now we can obtain the second term of the sequence, that is b2, as b2 is equal to b1 into 2, that is 1 into 2 is equal to 2. Now we can calculate b3 by using b2. Okay, so b3 is equal to b2 into 4, that is 2 into 4 is equal to 8. Now we can calculate b4, that is fourth term of the sequence, by the help of the third term of the sequence, that is b3, that is b4 is equal to b3 into 6 is equal to 8 into 6 is equal to 48. Now we can calculate the fifth term of the sequence, that is b5, by using b4, that is b5 is equal to b4 into 8, which is equal to 48 into 8 is equal to 384. And now we can calculate the sixth term of the sequence, that is b6 is equal to b5 into 10 is equal to 384 into 10 is equal to 3840. Thus, the pattern follows a rule, and we can summarize this rule with the help of a terms position. So I can write down here like this. So thus, thus the pattern follows the rule. The pattern follows the rule. Thus the pattern follows the rule. I can write this rule as Bn, where n is the position of the term. Okay, Bn is equal to Bn minus 1 means preceding term. Here in B2, in order to calculate B2, we use B1. In order to calculate B3, we use B2. For B4, we use B3. For B5, we use B4. And for B6, we are using B5. So in order to calculate n term of this sequence, that is Bn, we will use Bn minus 1 into, and we can see a pattern here in this multiplying number, that is in 2, 4, 6, 8, 10. I can express this multiplying factor in terms of the terms position like this. So Bn is equal to Bn minus 1 into 2 into n minus 1, where n is the, so I will write down here where n is the terms position. Okay, where n is terms position, where n is the terms position. Okay, so you can verify this rule by substituting the value of n for respective number. For n is equal to 2, 3, 4, 5, 6, etc. Okay, so in the step 3 we will write down the general formula, which is nothing but the rule that we have found here. Okay, and that will be the general formula for calculating the n term of the sequence, and along with that we will also write the first term, that is b1. Okay, so step 3 is the general formula. The general formula for n term is, I will write it down in the red color for highlighting. So Bn is equal to Bn minus 1 into 2 into n minus 1. Okay, provided that that is with B1 is equal to 1. Next step we will try to calculate the 7th term of this sequence, because at first in the question it was mentioned that we need to find an equation and 7th term of this sequence. Okay, until now we have found the general formula for this sequence, and now we will try to find the 7th term of the sequence, that is we will try to find the B7. So in the step 4, for n is equal to 7, by using the formula Bn is equal to Bn minus 1 into 2 into n minus 1, which I have mentioned in the above step, we can calculate B7. So B7 is equal to what? B7 minus 1. I will give bracket to this into 2 into 7 minus 1. So 7 minus 1 will be 6, right? So B6 into 2 into 6, right? 7 minus 1 will be 6. So B6 is actually what? 6th term of this sequence is already given, right? 3840 into 2 into 6, which is nothing but 12, right? That is, we need to calculate a multiplication of 3840 and 12, and which is nothing but 46080. Okay, and it will be an 7th term of this sequence. Okay, so I will write down this 7th term of this sequence again. Thus the 7th term is, I will write it down in a red color. Okay, so B7 is equal to 46,080. Okay, so the final solution of the problem A from IYMC will look like this. So in the previous video, I have already explained how to calculate the seventh term of the sequence en, and we have also found the equation for the first sequence. And now here in this video we have calculated the formula for calculating the n term of the second sequence, that is bn, calculating the seventh term of this sequence b7. Okay, I will show the solution once again so that you can take a screenshot. Okay, just a minute. Okay, and that's it. We have successfully solved both the sequence from problem A of IYMC qualification round. If you found this video helpful, don't forget to like, share and subscribe to the channel. I got more math challenge and problem solving technique coming your way. So make sure to hit the notification bell so you won't miss out. And feel free to leave the comment below if you have any question or suggestion for the future topic. Thank you and bye bye.